Hello and welcome back, AP Stat students. Welcome to our final example on the Chapter 12 outline. Now, this is a brand new kind of design that we're going to be learning about today, a new name, but actually we're going to see that this name, matched pair, is very similar to the design that we've learned about previously, randomized block, okay? In fact, matched pair is randomized block. It's a type of randomized block design. It's just that given the name, it is randomized blocks where your blocks are pairs. In other words, your randomized blocks come in twos. We're going to look at an example together. So grab your chapter 12 outline, make sure that you're writing all of this down because it's going to be great to go back and reference. And also make sure that you have something, maybe an extra paper to write on, because we're going to be doing the write-up as well as the map for this one. So let's talk about matched pair design. While I'm talking a little bit about this, go ahead and copy this picture on your example. So we've got an interior designer and they're deciding upon furniture for a large-scale project to be used in furnishing luxury movie theater rooms. So this is a really nice theater room. Maybe they're going to do this inside of a really beautiful mansion house. I would love to have one of these, like a media room. A very small media room with a giant screen at the front and a heater at the rear is arranged as shown below in the picture. So we've got these 8 chairs, 1, 2, 3, 4, 5, 6, 7, 8 chairs in front of a screen with a heater in the back. I've got a little door here that can open and close. And I've got, just for fun, a popcorn machine in the corner. What we're testing is to see if the fabric, which one is more durable. So we have 2 options, ultra suede and leather for the chairs. The final choice comes down to wear and tear and sustainability. Design an experiment to test the 2 fabrics. Okay, so let me talk a little bit about this. This is a specialized kind of blocking, like I mentioned previously. The thing is, there are multiple confounding variables. So yes, matched pair is great to use when you see that there are multiple confounding variables. For example, I have a heater. Oh my gosh, the heater could maybe influence the wear and tear of the cushions and the fabric, right? The door, I don't know, maybe that would. But the popcorn machine might get kind of greasy and oily, and that could really break down the fabric if it's not really durable fabric for the chairs. I don't know, maybe the screen exposure. Okay. So notice that what we're going to be doing here is we labeled our chairs 1 to 8. I have that in my picture. That's going to be part of my write-up for experimental design, is talking about giving these chairs 8 different numbers. But before we get to that, it's important for us to consider, how do I know on an AP exam if it's a matched pair? Well, I just mentioned one thing previously. If you've got multiple confounding variables, it's very easy to do matched pair. But the biggest hint is that most often on AP exams, if you see a picture and you're asked to design an experiment, if it's a picture, it's probably a matched pair experiment. And then if you check to see on your picture if things are divisible by 2, well, then you know you definitely could make pairs, right? So let's talk about, for this particular question, what would the map look like? So we've got our experimental units. And those experimental units are our chairs. And there are 8 of those chairs. Okay, and what's going to happen is, like I said, it's a block. We have some blocking we need to do. So we're going to go ahead and block by putting them in blocks according to location. Okay, because I think that the location of where these chairs are in the room, if they're close to the heater, if they're close to the popcorn machine, I think the location could potentially be a confounding factor. So I'm going to block based on location, 1 and 2. Why are 1 and 2? They're kind of up here, just close to the screen, chilling. Okay, may not be, they're going to be affected by the heater maybe similarly though. So the next blocks are going to be 3, and 4. Okay, maybe not as much popcorn grease is going to get up to seats 3 and 4. Then we've got 5 and 6. Okay, 5 and 6 are going to be affected by the heater. And we've got 7 and 8. Now we've got 2 different kinds of fabrics that we're going to test out. Now it wouldn't make sense to just give one, for example, to give 1 ultra suede and 2 leather, and not actually get to compare those, right? We want to be comparing in this situation. So what we're going to do is assign 1 and 2. So there's going to be 1 that's going to be assigned to treatment group 1, which could be the ultra, for example, and treatment 2 is going to be the leather. Okay. And then we've got treatment. Now notice I'm rewriting treatment 1 and treatment 2 because either 1 or 2 is going to, have the ultra, the treatment 1. Now all of these are going to be involved in treatment group number 1. If you have the ultra fabric, you're in treatment group number 1. Treatment 1, treatment 2, ultra, leather. Treatment 1, treatment 2, ultra, leather. Okay, and if I wanted to, I could go through all of these and I would say, you know what? There's going to be 1 that receives each of these. It's really easy if you're just assigning 2 chairs to 2 different treatment groups, okay? And then you're going to take all of these. Remember, we're going to just connect all of them. And they will all get connected to our response variable because we need to check the response variable for all of our treatment groups. Now, in this case, we're measuring and comparing. It says here, the final choice comes down to wear, tear, and sustainability. Okay, so it's the same idea, wear and tear, sustainability. Okay, so let's go ahead and fill in some words that we have not already written down. So we know that in order to get them into these groups, we are blocking based on location in the room. Those are my blocks. I could write blocking if I wanted to. And I'm also going to make sure that when I assign a certain kind of leather or ultra suede to these particular blocks, that I do it randomly, okay? Because maybe I would say, oh, well, I really want the ultra suede to show that it's the better. So in my 1 and 2 block, I'm going to put the ultra suede a little bit further away from the heater. No. Remember, randomization reduces bias. So please make sure that you are keeping randomization in there. Okay. All right. Let's go ahead and get cracking on the write-up here. So we've got our example number 5. This is our matched pairs. So we can kind of start with just giving a little bit of context to test different fabrics for durability. I will design a matched pair experiment. All right, so I'm still stating what kind of experiment I'm going to be doing. How am I going to get my experimental units if I'm looking at my graph? How am I going to get those 8 chairs? I will purchase 8 identical chairs from, I really like IKEA. I'm going to go to IKEA for these. You can get tons of identical things from IKEA, right? And those will be my experimental units. All right, now I've got to talk about my blocks, okay? I will create the following blocks. Okay, so now this is where you want to be careful. Don't assume that the AP reader knows what your blocks are, okay? Because they don't. And what are we blocking on? Well, we think that location in the room is a confounding variable. So we're going to block based on the location of the chairs in the room. I will write, so I've already assigned the numbers to the chairs. I show that on the diagram. If you don't have a diagram, you need to explicitly say that you will assign each of your chairs a number, but we already have assigned that. So I will write the numbers 1 and 2 on identical slips of paper and place into my magic hat. Shaking, here's our little keyword here, so to speak, making sure that we're making it totally a legitimate way of doing this. We are shaking between each draw and without replacement. Okay, the first number drawn will be the chair. Okay, now this is where I get to decide. Will the first number go into treatment group number 1, or will the first number drawn always go into treatment group number 2? Okay, so I'm going to define that. The first number, if I draw a 2 first out of the bag, what's going to happen? They're going to go to the first treatment group, no matter what. First number drawn will be the chair to go to treatment number 1. And be covered. Now, what was treatment group number 1? Oh, yeah, we're going to cover it with ultra suede. Great. The other chair. So remember, if I drew, maybe I drew a 2, okay? Then that means chair number 2 is going to end up in treatment group number 1. Well, that means chair number 1 is going to be assigned to the other treatment group, which is the leather. The other chair will receive treatment number 2, leather fabric. Okay, I will write 3 and 4 on identical slips of paper. Okay, notice what I'm doing here. What I'm doing is I'm repeating this process, this magic hat process separately for each of the blocks. We did this when we did randomized block design. it's important that you're not putting numbers 1, 2, 3, 4, 5, 6, 7, 8 all into the magic hat at one time, because we're blocking first. Okay, they were all in the same hat at the same time. That would be a completely randomized design, similar to simple random sample. I will write 3 and 4 on identical slips. I'm just going to copy what I did over here and place into my magic hat. Just copying here, shaking between each straw and without replacement. The first number drawn will receive treatment number 1 and be covered in UltraSuede. Okay, so if the first number I drew was a 4, 4 would get covered in UltraSuede. And now what I'm going to have is, okay, the same thing, the same rigmarole is repeating over and over again between my different blocks. So between 1 and 2, 3 and 4, 5 and 6, 7 and 8, I would just have to keep repeating and writing it over and over again. Okay, the other chair will receive treatment number 2, leather fabric. Okay, so I think you guys are getting the picture. We're doing this over and over again. Okay, so I'm gonna magic hat for 5 and 6. I'm gonna magic hat again for 7 and 8. Okay, so what happens when we get to that? What do we do next? Okay, so now I've got to think about, after I've talked about my randomization and how I'm going to assign all of those, okay, I'm going to talk about now what kind of variables or what things I should control here. So I will make sure every chair, what things could also potentially affect the sustainability of a chair? Well, how much a person sits in it, right? So I'll make sure every chair receives the same amount of love. We'll put usage. And we could also talk about cleaning. How you clean the chair could be important. Equal exposure to cleaning. You can probably think of some other things that we could control here. Now we got to talk about when we're going to do it. When are we going to end this experiment? So after 6 months of daily movie viewing, I will hire a fabric specialist to measure and compare the wear, tear, and sustainability. So I'm just plagiarizing right now from the original problem of the fabrics. That way I can make a decision. I want to know. Okay. So that is how we do our wonderful, beautiful matched pair design. Okay. Hope that helped. See you guys soon. and have a great rest of your day.